calculating energy costs. So remember, the units of power are in watts. You can convert watts to joules per second. You can also convert watts to kilowatts. Here's the conversion factor. Remember also that since power is energy over time, then you can find energy by power times time. So often you know how much power something requires, and you need to find the energy because you are charged by the amount of energy you use. Your utility bill, or your parents' or guardians' utility bills, are for the amount of energy that's supplied by the company. So if you look at these bills, they're very complicated. So let's take a look. You're charged for absolutely everything. So look here at this sample. So you've got delivery charges, and you've got supply charges. So you're being charged for whoever's creating the energy and supplying it. And then there's another company that is going to deliver that energy to your house via the wires. So there are two parts to the bill. Now both parts have a threshold. So usually in this bill, it's from 0 to 600 kilowatt hours, you get a certain charge, some base fee. Anything above and beyond that has a different fee. Then, if you look, there's summer charges versus winter charges. So they charge you different rates depending on the time of year. When there's high demand in the summer, often the charges are higher than in the winter when you don't use as much electricity, right, because of air conditioning. And then, of course, there's like all sorts of miscellaneous charges and things we're not going to talk about right now. So here's a sample bill, and I want you to go ask your parents if you could see their electric bill, because I want you to notice it's structured pretty much the same way. It's not going to look exactly the same because it's probably a different company. But look, first thing, they have a meter number because every house or apartment has its own meter. So they do a meter reading. Sometimes they'll estimate and sometimes they'll have an actual, right? They do an estimate based on previous, because the people who read the meters don't come out every single month. They come out every so often and then they'll adjust if they're wrong. So here's the previous, right? Here's the previous, here's the current estimated bill. So this was June, here was July. The difference is how many kilowatt hours of electricity you used in that 1 month. Then they have the delivery charges. So there's a service charge, and then for the first 600 kilowatt hours, they charged 4 cents, or a little over 4 cents. Look at how many decimal places they pulled that out of, right? Out to. So they've got the 750 kilowatt hours that this family used. So the first 600, you get one charge. For the next 150, notice this total is 750. So 600 plus 150. So you have 150 that's charged at a slightly different rate. Notice it's higher. Okay. Then they do the same thing for the supply charges. They add up the delivery charges and the supply charges. So now, the reason why they split those, because that wasn't always so. It used to just be that whatever your local company was, they had a monopoly and you would have to use that company for both supply and delivery. But now you have choice. So if you want to support the wind farm out in North Dakota, you can actually request to use them as your supplier. If you want to use the solar farm in the upstate New York, you can find a company and you can request to use them as your supplier. Now their charges may be higher or lower, right? But you might want to do that if you find that to be something important. So that's when they split this up. They made the companies give a choice so that you could, as a consumer, do that if you wanted to. So that's why those are now separate. And then you get a total bill from that. So this is the part that trips people up sometimes. A kilowatt hour is a unit of energy, right? It's power times time. Right, so you can pretty much find that because most appliances have its power rating. So you can just read it right off of the appliance. Again, the company, you're not paying for the power, you're paying for the energy. So they supply energy at 110 to 120 volts. If you have a 220 line, they'll do that too. You don't even have to ask, it happens automatically. That's what transformers do. But the utility company is providing the energy that you need. And then they charge you for it. A lot of people think that the utility company provides the electrons or the charges. That's not what's happening. They just provide the energy. The electrons are already in the wires and they just deliver the energy to your house. Take a look at this problem. If you have a 60-watt light bulb and it's plugged in and left on for 3 hours, what's the cost of the mistake if the company charges you 11 cents per kilowatt hour? So there's a bunch of steps that you need to do. Okay, one is convert the power rating to kilowatts. So that's the first thing. Then you need to write down, what the cost of energy is. That's a given. And then also record the given time, which is 3 hours. Then you're going to use the power equation to find out how much energy you use in a full day. Right, so you do power times time. So this is the power, here's your time, multiply those two, you get 0.18 kilowatt hours per day. Then you can calculate the cost. So you're spending 11 cents per kilowatt hour for 0.18 hours. That's only 2 cents per day. Not really a big deal, but you'd be surprised how quickly this adds up over the course of a month. So first you have to estimate the power rating of the light bulb. So let's just say it's 60 watts, right? First let's convert that to kilowatts. So it's 1,000 watts in a kilowatt, so move the decimal place over 3 places. Then you have to estimate the cost of the energy as charged by the utility company. So generally it's about 12 cents per kilowatt hour. You can look on the bill or that's given to you. So let's assume it's 12 cents per kilowatt hour. Figure out the time. So in one day, there's 24 hours. Now let's use the power equation to find out how much energy you use. So energy is power times time. So you take the power, 0.060, and you multiply it by the time, and you get the total energy used is 1.44 kilowatt hours each day. Then let's multiply that by 12 cents per kilowatt hour to get 17 cents per day. Well, again, you might be like, wow, it's 17 cents, who cares? But when you add that up over the course of a month, that's $5.20. In a year, that's over $60. So that is a lot of money, especially if you multiply that by many bulbs, maybe that get left on for a whole day or for part of a day. You know, all that waste does add up over time. Another good thing for you to take a look at is this exercise with this gizmo.